In this video, I'm going to demonstrate emitter mode switching for range and time events. I've already created and loaded a scenario. In this scenario, we have two friendly platforms, F-18-1 and -2, flying low towards a threat platform. The threat platform will add a search radar and a track radar, and we'll demonstrate the switching of modes for those radars based on range and time events. Going to open the properties dialog of the threat platform and add a new emitter. And the first emitter I'm going to add will be the search emitter. And in that search emitter, I'm going to have it be a helical scan type emitter. And we can see it doing a helical scanning pattern right there. And I will set this to be a frequency of 2250, for example. Alright, and I want this emitter, the search emitter, to turn on at the beginning of the scenario, or near the beginning of the scenario. It'll be by time event. And so I will set it to turn on at 10 seconds. So 10 seconds after the scenario begins, the search emitter will go to mode 1 and begin searching. I'm also going to add another emitter, and we're going to call that one track. And in the track emitter, I'm going to make this a electronic scanning emitter of type lobe switching, and the lobe switching parameters look good. I'm going to go into the frequency and set it to be 5500. I'm going to make the PRI 100 and pulse width 1. Alright, so we now have two emitters. The first one, search, will just turn on by time. The second one, I want it to turn on by range to platforms of interest. So first I'll go in and add two platforms of interest, both -1 and -2. A platform of interest means that the platforms will cause a range event to occur and will also be platforms that get tracked. So in the range event, I'll add the range event itself. Say I want to go to mode 1 when the range gets to 8.1 nautical miles. So when either of these platforms get within 8.1 nautical miles, they will be tracked by the track emitter in mode 1. Now, in order for the range event to execute, it actually has to have a line of sight, and we'll demonstrate that right here by going to the tools, and we'll do a small analysis on this scenario. I'll change it to a radar analysis, and we'll do mean sea level, and we'll only do 30 nautical miles, for this is only illustration purposes. And the target height is going to be the height of the two platforms at 6,000. And I need an ERP, which is fine there, and a sensitivity right there. So I'm going to go to do my analysis for threat 1. And this analysis will show where the line of sight is. You can clearly see that the darkened areas for 6,000 feet are not visible from the location of threat 1's antenna. Being a radar analysis, any platforms that get within the green that have a 100 meter cross section for RCS should show up to that particular radar. Although that's not actually part of the range event, just the line of sight is. Alright, so we'll run the scenario, and at 10 seconds we should see the initial search radar come on, and there it goes. And I'm going to go to -2 and set up the signal analysis view, And I'll do the same for dash 1. And when dash 2 gets within visual range, dash 2 signal analysis should be able to see the emitter, the search emitter. And it's getting closer. Alright, so we now see the search emitter coming on for dash 2. When at 8 nautical miles, we should also see, there it is, the track. So the track is now tracking dash 2 because it has line of sight, and dash 2 is within the range event of 8.1 nautical miles, which happens to be the unambiguous PRI range here. But is not going after dash 1 until after it actually has line of sight. So even though dash 1 was closer, which is the priority for range events, it didn't actually start tracking it until it came over the hill and was visible. And that demonstrates range and time events in a small scenario.